test preview for September 3rd, 2019, Algebra 2 Honors. The screen aspect should be different here from most of my other videos, and that's a long story, but let's just go with this. So we have a test next Tuesday, and I want to go over some of the types of problems that will be on the test. First one, solve, show, answer graphically with set builder and interval notation. And so we have inequality here, and we're going to first distribute to the terms on the inside, so we get 6x, and 3 times negative 4 is minus 12, and plus 5, and that's going to be less than or equal to 2, minus 3 times 3, which is minus 9, and then negative 3 times negative 2x is going to be plus 6x. And the 6x and 6x cancel on each side of the inequality. On the left side we have negative 12 plus 5 is negative 7, and that's less than or equal to 2 minus 9, which is also negative 7. Now question, is this a true statement? Is negative 7 less than or equal to negative 7? Yes. And that means that no matter what value x is, because x is canceled on each side, this is going to be a true statement, meaning that the domain for this, or the solutions, will be all real numbers. And it says set builder notation. Set builder notation is going to be brackets x such that x is greater than negative infinity. Let me leave myself enough room here. To do that, I can just start writing out negative infinity. Negative infinity is less than x, which is less than infinity. And there we go. And also interval notation, that's going to be this here, put in parentheses, negative infinity, comma, infinity. And then lastly, graphically will be a number line notation. So here we go. So 0. Graphically, we have all real numbers, draw arrows on each side. That will be a graphical representation. So look out for a problem very much like this. C1 equals V1 equals C2, C2 V1 equals C2 V2, solve for V1. So to do that, if we divide both sides by C1, we get V1 is equal to C2 V2 over C1. So that should be quite a simple solution. Next, the smaller of two numbers is 3 less than 3/4 of the larger. If the sum of the two numbers is 172, what are the two numbers? There are a lot of ways to do this, one of which is to work something out, work it out in your head. I had a few students who did that. But we can solve this as a system of equations. We say let x equal our large number. We can say let y equal small number. And so having set these up, we can say x plus y, the large number plus the small number, is equal to 172. And also the smaller of two numbers, well, we also said the small number is y. Y, the smaller of two numbers, is 3 less. Well, 3 less is a switch word, So we can go ahead and put minus 3, 3/4 of the larger, so 3/4 x minus 3. So what we can do for that is we can say, we can solve this as a system of equations. We can solve by graphing. If we solve for y, subtracting x from both sides, we have y is equal to 172 minus x. And now we can go to a calculator, and here I am in my function editor view. So we have 172 minus x, and then we have 3/4 x, and I'm pretty sure that was minus 3. Let me just be sure. Yeah, minus 3, and then we can graph this. I don't see but one line, and that's going to be the 1/2 x minus 3. But to find our solution, we can go to our window. Well, I know we have 180 is our biggest number. Let's go ahead and our x max will set at 180. Our y max we can also set at 180. We're guaranteed pretty much to be able to see everything. And we graph, and we see this intersection point, the center, the blue and the red line. And to find the intersection point, we can press second, trace, enter, oops. I don't know what happened there. Second, trace, oops, I want to go back here. Let's try it again. Second, trace, 5, enter. I don't know what I did wrong, but anyway, our larger number is 100, our smaller number is 72. So x equals 100, and y equals 72. And since we already defined let x equals large, let y equals small, we can let this stand as our answer. Now one of my students will set this up as a single equation. If you say let large number plus small number equal 172, well, we already know x is our large number, and our small number y is equal to 3/4 x minus 3. And we know that these two add together are 172. And so if we can solve this equation, add 3, we get, well, I'm going to rewrite x as 4/4 x. And we've added 3, so we equal 175. And then we have 4/4 plus 3/4, that's 7/4 x equals 175. And if we just multiply both sides by the reciprocal of 7/4, which is 4/7, so here's 4/7 on the left, 4/7 on the right. We have x is going to be equal to 100. And then we can work backwards from there to find what y equals to. 3/4 of 100, 75, minus 3, 72. Okay, the last one we're going to look at is one like this. Change to slope-intercept form. Use -2, -1, 0, 1, 2 for x values. Make a table, plot the points, and graph. And so on your test, there's going to be a little graph paper, but we're going to take the points here. I'll put -2, -1, 0, 1, 2. We have this equation right here. It's in standard form. Change to slope-intercept form. That could be very helpful. Well, we'll do that right now. We want to solve for y. Add 3x to both sides. So we get we get 5y equals 15 plus 3x, and dividing by 5, we get y equals 3 plus 3/5 x. So therefore, our m is going to be 3/5. Our y-intercept is 3, so we can write that as a coordinate pair of 0, 3. Our x-intercept, well, one way to do the x-intercept, we can cover up what we want. We can cover up the y. So if we say we let y equal 0, negative 3x is equal to 15, and we divide by negative 3, solve for x. X is equal to negative 5. So that would be our x-intercept of negative 5, 0. So we have a slope-intercept form, and actually that is not slope-intercept form, is it? Because slope-intercept form, really, if we want to get picky about it, we have to write that as y equals mx plus b. So y equals 3/5 x plus 3. There, that's really what it is. And then really to fill this in, one thing we can do to make this pretty quick, we already know our y-intercept is 3, so at 0 we have 3. We know our slope is 5/3, so 3/5. So we multiply. I don't know if I could get this right. That'd be great. 3, there we go. We're going to add 3/5 to each iteration here, and then add another 3/5. One way to do this is we can go to our calculator and type that in. So we go back to one, clear. So we have 3/5, 0.6, that's 0.6x plus 3. We can go to our table view, second graph. So we're going to have these numbers here. And I'm going to go up here. So we have 1.2, 1.8, 2.4. So we're going up 0.6 every time. Okay. 1.2. So we go up 0.6 every time. That's going to be 1.8. Yes. 1.8, 2.4, 3. We add 3/5, we get 3.6. If we're in 0.2, we get 4.2. And so really that's it. You can do these problems here, which are really some of the harder types of problems that are going to be on this test. You're going to do well on this thing. So as always, good luck, and thanks for viewing.